Another nice thing about event-driven programs is that they are surprisingly actually easier to test. One of the reasons is that the callbacks by their nature are small actions that respond to a particular event. It starts to feel not like one big gigantic hairy program, but lots of small simple things, each of which are supposed to do a well-defined function. And those well-defined functions can be tested. We've talked about testing before, about writing tests for each component of your program to make sure it does exactly what you want. I also mentioned that there was a more formal mechanism for doing that, and that's what I want to talk about. The more formal mechanism is called unit tests. A unit test is simply a test of an individual unit. It's not a system test that checks whether the whole program does what it's supposed to by having a user sit down and use it, but rather it takes each individual component and tests the smallest part that it can to make sure that it does exactly what it should. If you have something as simple as adding a person to a phone book, well, a test is check the phone book before you add the person, then check it again and make sure the only difference in the phone book is that the new person was added. Right? If that's what the function is supposed to do, then make sure that it does it. It seems sort of straightforward, you've written your code right, but the point is programs can break in all kinds of unexpected ways because maybe someone 2 years from now doesn't understand how the add method should work and they do something different. And if you have that test, that unit test, or hundreds of unit tests, or maybe thousands, then it's going to check every single individual component. And actually the way that serious developers work is they have a process so that every time a change is made to the program, all of the unit tests are run. It tells you if any change you've made might have broken something. In fact, the process is even better than that. Most people use what's called regression testing. That is, they do what I just said with unit tests that run every time you make a change, but in addition, every time there's a bug, before you fix the bug, you write a test that demonstrates that that bug is occurring and that it breaks the system. Then you go fix your bug, make sure that your test stops indicating an error, and that test is now part of your unit test system, and in the future it's essentially impossible to have that bug again, because if you introduce the same bug, you've got a unit test for it that will indicate that problem immediately, since that unit test gets built every time you make a change. So, how do we do this unit testing in Python? And the answer is we use a package built into Python called, you guessed it, unit test. Let's look at unit test and build a test for our simple grid that we just wrote. Well, simple grid doesn't do very much. In fact, there's only one substantive method in here, which is move. So let's see if we can write a unit test for move. This is how we do it. We start by importing unit test, which is the package that's available, and we want to also import the code we want to test, event loop 2. So from there we'll import everything. And now the way that we write our test is we just define a new method, name it anything you want. I'll call it test simple grid, and it's actually going to use a new language feature which we haven't talked about, so just bear with me for the moment. We're just going to put in parentheses when we define this class unit test.testCase. This is actually using inheritance, which is a more advanced language feature which we'll learn about before long. This is saying that test simple grid our class builds on top of an existing class called testCase. Okay, so what our class is going to do is define some tests that we want to run. Before we write our tests, the first thing we need to do is write a special method called setup, and this is going to get run before every test. This is just a convenient way of doing whatever kind of setup we need, any allocation of variables or classes before we do our testing. And in fact, we need one. We need an instance of our simple grid. So we're going to make our simple grid and store it. Now every test will have access to that grid. Now we can go ahead and write our methods that do the testing. We can write as many tests as we want, and the way we do that is by writing a method that starts with the letters test underscore. This test in lowercase. So I'm going to say we're going to test the move method. The rest of the method name doesn't matter. It's common to just give it a name that is representative of what it is that we're testing. And so what we might do is say move in a random direction and make sure we still are within the grid. Well, to move in a random direction we need that random package, so let's go ahead and import random. And now we can define how much we want to move. A new row delta, and let's go ahead and do some basic stuff here. Generate a random integer, and we can move between -1 and 1, right? So it'll generate either -1 or 0 or 1. And then we'll do the same thing for column. Now we can go ahead and move. Self.grid, right? We get access to that grid we just made, and we call the move method and pass in a list, because it wants a list of row delta and col delta. Now we need to do the testing part, which is to make sure we've moved in a way that is valid. So let's get the location of where we are. I'm just going to store it in a temporary variable into me, self.grid.me, just so I don't have to type in self.grid.me all the time. And now we're going to use the special stuff that comes with unit test, which is a bunch of methods that you call to assert that things are the way they're supposed to be. So let me say that again, that's a little tricky. The way that unit tests work is, rather than trying to break things, what you do is you try and demonstrate that things are correct. We've just executed some code. We know what is supposed to happen, so let's ensure or assert that what we think has happened has happened. What we want is that me should be on the grid. That is, we want me's row location to be greater or equal to 0 and not too big. And we'll talk about that in just a second. So there are a bunch of methods built into test case which we get access to because of this special inheritance that we haven't talked too much about yet. And there's a bunch of assert methods. And if you start typing assert, PyCharm will tell you, it'll show you a list of all of the assert methods, and there's a bunch of them. For example, what I want to do is I want to assert that the row location is greater or equal to 0. So you pass it two parameters. And the first parameter, in this case, is the thing you want to check. It's row column, that means it's row value, and we want to check that it's greater or equal to 0. So this is a method that says this asserts the row should be greater or equal to 0. If it is, there's not going to be a problem. If it isn't, well, that will be a problem, and we'll get an error. Now let's see, that's its minimum value. The row's maximum value should be 1 less than the dimension of the grid, right? The grid is dim, in this case it's 5, but it's the variable dim, and since the valid values go from 0 to 1 minus, what we want to do is say we want to assert that strictly less than me of 0 and that dim value. Now how do we get access to that dim value? Let's take a look at event loop. Remember, this was a member variable or a class variable. So the syntax is a little bit different to access class variables. When you access instance variables, you access them with the dot notation after self, right, after an instance. But we don't have an instance. This is for the whole class. So the syntax is just to say the class name dot and then the member variable. So assert less than class name, which is simple grid, dot dim. Okay, and let's do the same thing for the column. We'll assert that me of 1, which is the column, is greater or equal to 0, and that me of 1 is less than the dimension. Okay, we've written our test. Now, the way we run it is by calling unittest.main, which will cleverly look for all of the subclasses of test case, and then look for all of the method names that start with test and run this test. Before I do this, I've got to do one thing, which is our event loop program actually had some testing code already in here, so I'm just going to comment this out. We don't need to be printing that. Alright, let's go ahead and run test, and with any luck, it will work. And look what happened here. The output of this is the testing framework, the unit testing framework. It printed out one little dot because there was just a single test. It said it ran one test and the result was okay. Excellent. It seems like we're in good shape. But are we? Is this a good enough test? All we did is move in one random direction, and we started in the middle and our grid is pretty big. If we were to have a problem, shouldn't we move a lot? Right? What if you had to make several right moves in a row to get off the grid? Or maybe there's some strange feature which first if you go left, then you go right, and then you go up, then there's a problem. Right? If we want to have a better test, we would do this a whole bunch of times. So instead of just doing this once, let's do this a whole bunch of times. But we can do that really easily, right? We can just iterate for I in range of, say, maybe 100 movements. And this code, we can just do this over and over again, right? Generate a random number, move, and make sure it's right. Let's try this test. Ah, what happened? Fail. Test move. Line 17, self.assert less. Assertion, 5 is not less than 5. So this is the line number that we were testing. The row is supposed to be less, strictly less than the dimension, which in this case was 5, and this test said that failed because it wasn't strictly less than 5. It actually had the value of 5. It was equal to 5. Guess what? We found a bug in our program. Let's take a look and see if we can figure this out. Now, this was a case which I admit I had put this bug in on purpose, and perhaps you noticed. What happened is in our move, when we did our checking for valid values, right here, I said new row is less or equal to dim when we should have required that it was strictly less than dim. And same thing with columns. And this bug didn't come up when we were just doing some simple testing on the keyboard by typing left and right. And this is the nature of bugs. Sometimes you can write your code where there is a real underlying problem, but you don't witness it when you're testing it because you don't give an input that results in the bug exhibiting itself. And that's why having good, really tough test cases that really bang at your code and put in all kinds of random input and move hundreds of times is really what's required sometimes to find the bugs. All right, let's go back to our test case and see if that fixes it. Run it again. And look at this. We ran our test case, and everything is A-OK. All right, we only wrote one test case. I actually don't have any other test cases in mind. But just so you can see, if you wanted to write other test cases, all you have to do is you go to find another method. Test, well, I'm not going to write a real one, XYZ. And we'll just assert equal that 1 is equal to 1. Well, this test is surely always going to succeed. But just to see what happens when we have multiple tests, we run this, and now it says we ran 2 tests. All right, that's enough of unit testing.